think we're ready. Got a couple of things to do today. We'll look at Octoprint some more. I never did go back and fix it up to make sure that it's not going to have that error again, but we'll see what happens with it. Mainly I wanted to look at some of the plugins that you use with it anyway, or at least one. We'll see. I also have the little Voron V0 over here. We'll look at that some. And then I've got some more prints and a tool or two to look at. So it's just a kind of an assortment of things today. Let's look. Well, let's start with Octoprint. So let's go over to the printer. That's actually the Voron. So let's look over here. I did find the little switch. So this little piece is kind of handy because Raspberry Pis don't have an on-off switch. You just plug them in and they're on, and you unplug them and they're off. So this little guy is just a USB switch, and you have a little button there that you can turn on and off, so that you plug your power in and then you can turn on or off. So that's kind of a handy thing. This is called the Pi switch from Cana Kit. I don't know if you can see the name on it there or not. It's too small, but it's the Pi switch. They probably have these that are not specific to the Raspberry Pi. I believe this one actually came in one of the kits. You do have to make sure it's got the right end on it for what you want it to do. So this one does. Some of these are USB-C is why I say that, and that won't plug into the Raspberry Pi. At least not yet. I don't think they have USB-C on them currently. So you do have to make sure if you buy one of these that's not the Pi switch, that it's not a USB-C one. All right, so whoa, it's going everywhere. I'm not actually plugged into the printer right now because it's printing our latest sample. That's an actual wood feel filament. It should be done in like 2 minutes or so. So once it finishes up, I'll go ahead and plug into it. I'll go ahead and turn the Pi on, and I think it'd be fine to go ahead and plug in there, but I don't know if there's some kind of handshaking or anything that would kind of interrupt my print if I start up the Octoprint while the printer's already running. I don't know exactly what that would do. In the meantime, let's look at some of these other things I've printed. So they're down here. There's a couple. You see a little tiny one. We'll look at that one. So this is the not stainless steel, but the steel filled one. I just finished distressing it. I just went over it with a piece of a sanding block. So I think it came out pretty cool. Like I said, I don't know that it's any stronger of a material because you're not actually sintering metal particles together or anything. It's certainly heavier, so if you're looking for heavier, that's good. And it does finish well, and it printed really easily. It's just very expensive. I do need to test and see if it's actually any stronger at all. I don't anticipate it being any stronger, but we'll see. Speaking of test, I do have some test samples started. This is carbon fiber nylon from a different printer. I didn't print it here. This prints at 280 or 290, something like this. It's pretty high temperature to get nylon to print well. And this is carbon fiber infused nylon. Again, the carbon fiber here is strands, so it might give a little bit of increase in strength. A lot of what the carbon fiber does in these materials is it keeps warping down. And so that's usually what they're doing, but they might increase the strength some also over the base material. Nylon by itself is really flexible. This is pretty flexible also. What I actually wanted to show with this one was, so this printer, for whatever reason, has started giving, let's see, can we see that? Let's see. Yeah, you can see it there. So see how the edges are very ragged. So the bottom is textured, it's a textured build plate, so that's normal. But the bottoms are really ragged. If you end up with stuff like that, or seams, or a brim you want to get off, a really good way to do that is a deburring tool. Oh, we're zoomed in a lot now. So these have these little swivel tools on the end. The end tips are made for different materials, depending on what you're trying to deburr. So a lot of times you're using these, you've done a little CNC machine job or whatever, and you're deburring that. But they work just as fine. Some of these are for plastic. This particular one is for plastic, but they make metal ones. I don't know that it really matters that much when you're just deburring a plastic 3D print, but they do have some of these, and they're interchangeable. So you can pull these out and put a different one in. But they work really well for deburring. So let's, like right there, that jagged edge, you can come in there and it cleans it up right away. So if you need to clean up prints, these deburring tools they're not expensive at all. They're really pretty cheap, and they work pretty well for cleaning up edges on prints. So that's that thing. What I'm doing with these is I did want to go, and this is the ASTM plastic sample size. So I actually found it on GrabCAD, I believe is where I found it. Let's see, look over here. Oh, never turned that on. GrabCAD, ASTM Tensile. Yeah, there's a whole bunch of them. So there's the, I think it's this one, the D638. I think it's similar to that. I don't remember which one. I have to look up the actual standard number for which one is plastic. But maybe it is that one, and it's just a weird view of it. But they make ASTM is a standards testing organization, so they describe what these tensile tests should look like for depending on what you're trying to test. And it just happened to be that they're popular enough that somebody's already made the model for it. The standard is, a lot of times these standards are not free, so you do have to go and pay $60 or whatever to find the actual text of the standard. But this is, I'm assuming this does look like, I didn't measure, but this looks like what the standard is supposed to look like from what I have seen on the standard. And they have different types. Here's maybe an overview of the different types of standards for plastic testing, tensile testing. So anyway, I did that so that we can have a standard to actually tell, are some of these materials stronger. So I just printed one test. I might print the smaller one because, I don't want to take a whole bunch of time to print a bunch of these test specimens, because, I don't want to just test one against one. That might tell you something, but a sample size of one is pretty small. I don't have a whole lot of this material to test also, so I can't print a bunch of these. So I do need to figure out maybe a smaller version. I'd like it to still be a standard though, so that I could compare it to other literature if there's any out there. So anyway, I was doing that, and then it started giving the ragged edge, and so that's when I brought out the deburring tool. The other things I printed, I printed this. This one was, I think it's just a gold filament. I can't even find the bag for it now. Where did I put it? Oh, maybe they're right here. Yeah, there it is. So it's just a ST PLA gold from CC Tree, apparently. Nothing special as far as printing, and it printed well. So, and it's kind of on the shiny side. It's not like the silk Nightshade Elixir stuff that we did, but it did print well. Then, I don't even know what this one is. I just had it, and it looked kind of interesting, so I printed it. But I don't know what it is, other than it's a PLA and it's shiny glitter. Again, all of these that have the glitter and things like that in them, you really probably need a larger nozzle. So I am printing them with a 0.6 millimeter, and you probably need a hardened nozzle too. So the nozzle that's currently on the printer we've been using is a 0.6 hardened steel nozzle. Then I printed this one, which is a terracotta from Phil Alpha. Philo Alpha. I don't know if that's supposed to be part of the name or not. Oh, there they are, Philo Alpha from Italy. So I don't know. Again, I don't know if I didn't go look to see if they still make this or not. But it's supposed to be the color of terracotta, and it pretty much is. You know, it looks a lot like that. It printed normal. I am starting to notice, like in the surface, I'm getting a little, I don't know, you can't even really tell. Maybe you can kind of see it over in this, some of it. I'm getting some extra lines in here, a little bit out of place. I can't tell if I'm over extruding or it almost looks like I'm picking up the Z-axis because it's a repeating pattern, particularly in the bottom half. Well, no, this one goes all the way up through there. And it looks like it might be the pattern of the threads on the Z-axis. And so there might be a little bit of wobble that I'm getting. I'll have to check and see if that's what that is or what it might be. It really showed up on this one. Can't really see it on the shiny ones, that they hide it better, I guess. But this is terracotta, PLA. It worked well. It was good. And then we just finished a actual wood feel from Push Plastic. So there it went off the bed. It is a little stringy. I did print it slower, so I went at 80% speed. I'm using the same file for all of these and just changing the temperature when needed. This one, I change the, I don't think I changed the temperature on it, but I changed the speed. And I bumped the flow rate up at the beginning just to get it to actually start printing well. You can kind of see the bottom here is a little worse than the top part. This one actually does have wood, like sawdust in the filament. It prints like PLA, other than I did print it. I printed the same temperature. The bed was 60 or so. The speed, I did 80% of whatever I was doing before, which I think was maybe 50 millimeters a second, maybe 60. But I dropped it down just because it was, I don't know, it wasn't looking that great. You can kind of see down in here, there's some under extrusion. That line right there is missing. That could be that is where maybe the first part of this roll was a little bit bad. But I think it's just I was under extruding, because once I changed it somewhere in this range, the top part actually looks really good. There's a couple of little strings. It's a little bit stringy down in there, but that's not bad at all. And this one really even feels like cardboard. Like it, you would be pretty convinced that this one is made of cardboard. And this is 0.4 millimeter layer height, and it is hard to pick up the layer lines in it because of the kind of, it's, I mean, I know you can't feel that, but you can hear that it's got a rougher texture, like wood would have. So it actually came out really, really good. Let me go get the one that's the wood-like one, but doesn't actually have wood in it. So this is the one, this one is the one that we printed earlier that it's called a wood feel, but it doesn't actually have any wood in it. It's just made to look like wood. And here's this one that actually does have wood in it. You know, look at them side by side. This one does, because you actually get a variation in particles in there that you can actually see fibers. So I would say that this one is more wood-like. The other thing you can do with it, I did not do it on this one, but the other thing you can do with the ones that actually have wood particles in them is you can vary the temperature as you print. Like maybe print a few layers, 5 or 6 layers at a hotter temperature, then drop down to a cooler temperature for 10, 20 layers and go back up. And the temperature will affect the coloring of the wood, ones that actually have wood in them. And I didn't try that on this one. I probably should have. And it'll give it a little bit of like a wood grain. You know how wood has various colors in it. It'll give it more of that kind of look. So I would say side by side, the one that actually has wood in it does look more like wood. Feel-wise, they both kind of feel like cardboard. But this one was easier to print. I will say that. This one was just the PLA that is just made to look like wood. And it is easier to print, although this was not difficult to print. This could have been hard to print if I was on a 0.4 nozzle though. So that, keep that in mind, that a lot of these materials that have some kind of fill in them are much easier to print when you jump up nozzle's diameter a little bit. All right, so that's all our new. Oh no, I have one new material that I didn't print, but I wanted to show you. I'll try printing with it, but it's another one of the what you call them, TPU prints materials. It's this one. I don't even know if they still make this, but Ninja Tech. It's the eel, and it is conductive. So and it's a TPU, so it's a flexible. I didn't print with it. It's very rubbery, but I did go in and let's measure its resistance here. So, you know, in open air, or well, let's see, a regular piece of filament. Here's a piece of filament. So regular filament. You know, nothing on regular filament. But if you measure the resistance of this little guy, where's the end of it? So there, I don't know, to there, it does actually have an electrical resistance. Now it's a lot, you know, 3,500 ohms for 2 inches of it or so. But maybe it is conductive. I don't know. It is conducting right now. So we'll see. I'll try to think of something that we can print that would say it's actually conductive or not. It is way more resistive than a piece of wire would be, but maybe there's some way we can print, you know, and this is a pretty big chunk of it too. So once you print something thinner, that's going to increase the resistance. So we'll see. I don't know. We'll see what happens. I'll try to. I don't know if I've ever seen a model already made for conductive filament. Plus, it's more of the flexible stuff. I've really got to figure out a way to dry flexibles that works. I'm thinking of a toaster oven, because I found a toaster oven that's not crazy expensive, but it's a dehydrator also, and that toaster could help us try out the annealing. Remember, we talked about one of these materials in the past couple of days that you could anneal. Actually, you could anneal all of them, but one of them that was meant to be annealed. And to do that, you need a pretty low temperature. Plus, I don't want to go put this stuff in my actual oven. So I might try and track down a toaster oven for annealing and dehydrating, and see how that works. Because I haven't even tried to print this, but I assume, I don't know how old this is. They don't put dates on here. I should probably put the date on here myself, so I know when I got these things. But I am just going to assume that it's not going to print well right now, like all the other TPU that I've been trying to print. So that was an interesting one, but I haven't actually tried anything with it yet. All right, so let's look over here. That's, oh yeah, we're zoomed in. There we go. Let's try to connect up. All right, so let's go to the computer and see if we can get connected to our Octoprint. It was this one, I believe. There it is. Hopefully it remembers my password. Oh, okay, it did remember. Let's connect to the printer. There are new plugins. We'll those look fine. We'll mark that as red. All right, just to check that I don't have the I guess I could plug that webcam back into it, but let's see if I can find it. Oh, wow. Sorry. I'm not sure if it'll recognize the webcam on a hot swap like this, but we'll try. Yeah, it didn't recognize it. I don't know if I want to like reboot the thing. Let's see, it says we can Settings, webcam. I don't know. Let's see if we can. I think that's in here. All right, now it sees it. These are a couple of things that you can set on the webcam. The aspect ratio, if it needs to be flipped or rotated one way or another. Let's see if that still didn't load it here though. But there it is. That's active. Yeah, that's active. All right, so we can look at it, and now it's loaded here. Okay, good. So we can look at the webcam if we want to. All right, let's add a G28. I think this was one of the issues for our last time was that for whatever reason, if it's not homed, if the printer's not homed, I was having an error that Octoprint wouldn't go past. So I'm just going to home it now. So we can see I just sent it a G28 command, which is home all, and it is homing. All right. Last time I had loaded, I don't even remember where I found this. I just loaded a XYZ calibration cube. I think I just found it on the printer somewhere. Not on the printer, on the computer somewhere. So maybe we'll try printing that. It is, oh no, it's loaded with that wood filament. Let's unload the wood filament. That I will say, while this is heating up, so I get a little target, and then this should start ramping up over here. This has the Bondtech DDX. They don't actually make this version of it anymore. They've moved on to another one, and maybe this is a piece of why, but it is pretty hard to load the filament in. You have to get it just lined up just right, straightened out just right, pointed just right, to get it to load the filament easily, and that's a little bit annoying, but it does work eventually. What should we put in here that we haven't done? Let's see. What is this? Oh, this looks nice. So this is a Prusa Mint filament. Oh, we can't see. We'll load this. Prusa Mint. So that's from Prusa. They usually have really good filament. This one is a polychromatic one, so it's one that it says higher nozzle temperatures and different layer heights and diameters get different effects from this thing. Looking at the filament, it seems a little bit, depending on which direction you look at it, it's a different color, so it's like a flip-flop paint type thing. So most of the time it looks kind of green. Let's see if I can, oh yeah, you can see over here, it's kind of gray looking, so depending on which way it's reflecting, it looks gray or green, so that'll be an interesting one to print. Maybe we should print our vase that way. So let's unload. Are we heated up? Yeah. Unload our wood filament. For these sample rolls, you know, they're just loose rolls like that. You really need something like this where you can put them on a roll easily without having to actually spool them up on one. That one I'll search and see if I can find it again. It just came off of Thingiverse, I'm sure. But something like that you can print or buy. I don't know if I've ever seen one to buy, but you can print one. And that makes a lot of difference in these things. They still get tangled a little bit, but they don't tangle nearly as bad. Plus, to load them on the spool, when it's like this one that's split, you just put it on there. You know, there's no spooling it up, and even that helps a lot on these things not getting tangled. So even though it's, you know, it's loose and everything, that helps a lot. Let's see if I can get this loaded. All right, where are we at? I'll show you what I have to do to get it loaded. Normally you have to try and straighten this end out. so that it's not curved. Even that amount of curve a lot of times gives trouble with this extruder. And then cut a very steep angle so that I end up with something that's pretty spiky there. I don't know if you can tell, maybe. And then hope that we get it lined up right. And there it goes. It actually did that. So that was surprisingly easy after I said it was really hard. The flexible ones are very hard to load because they don't want to stay in any particular shape. And so that's a pain. I've said it before, these are really handy for getting down in there and getting hot molten plastic out of the way. All right, let's go back over here. Do I have Cura open? Yes. All right. So here we are. Let's load our, those are not going to print. That's for something else. Let's find where I might have put the vase. I think I just downloaded it. Yeah, there it is. All right, so I've been printing it just so you can see the settings that I've been using. I've been printing at half scale because it was just going to take too long full scale. So I've been printing half scale. I've been doing 0.4 millimeter layer heights. I've not been doing any of these settings because I've been doing a spiralized outer contour. And what 200 is, well, I've been adjusting the temperature. This is, oh, this actually says it prints at 210. So let's go up to 210, I guess. I'll do 215. Build plate is probably fine at 50. Print speed at 7. So the print speed I've been using is 70 apparently. Cooling, it's PLA, so we will cool it. And that should do. So let's slice. Preview, you always want to make sure you preview these things. That looks what I want. And let's see. Oh, let's see the time on it. 41 minutes. Maybe I've been doing 0.3 because they've been going slower than that. Maybe I've been doing 0.3 layers. Let's try that again. Yeah, I must have been doing 0.3 millimeter layer heights because that's more like the time I've been using. Although I don't want this to take any longer. Let's go to point. Oh, this is the shiny stuff though. I do want it thinner. All right, so we'll save that. And we'll just save it on the desktop somewhere. And this will be the I'll use the same file for the other stuff, but this one we'll just do here just to see what it looks like. Maybe we can do it really tiny so that it doesn't take the whole class. Why don't we do that? I printed another tiny one, like this little guy. Printed this one. So let's drop, and that one is quarter scale, so let's drop down to here. 19 minutes, okay. We'll try that. It'll be really, I don't know what it'll look like, but we'll see. 3 grams of filament, we got plenty of filament. So this will be the Mystic Green vase, but it's tiny. All right, yes, I want to override it. So now what I can do is, got my printer, it's preheated. The bed is not. The bed, let's go ahead and start it preheating. I can go to this panel and upload, and I can find my little Mystic Green vase G-code, open it, and I've got several options here. I can re-download it so that I can check it out if I want to. I can move it around if I want to, delete it. Let's see, what is this one? Load. I've already loaded. Oh, I could load it to the printer. I don't ever do that because that takes a very long time to do. Where even on small files, it will, if you're having slow internet or some kind of issues where your connectivity from your PC to your printer, the Raspberry Pi running your printer, is weak in some way, then yes, maybe it makes sense to load the file so that you're not relying on that internet connection. But I'm not going to worry about that because it is slow. So I'm going to do the load and print option here. So now it's set our new target. So we had the target at 215 and the bed at 50, which we already had it there. And so it'll try to get to the new target, and we'll see if it'll print. It's going to do a new homing routine though, so it might give us an error again. I don't know. We'll find out in a minute. We can actually watch it, see what it's doing. So that's the regular G28 home. Then that was okay. Now it's doing the G29 bed mesh adjustments. You can actually watch the G code. Well, this terminal shows it's not. I don't know if it'll show anything here because it's not extruding. Not yet, anyway. But there's that G29 command that it was sent, and so it's still doing that right now. It's going to do the. It's halfway through the, or it's about to be halfway through the mesh. There's the halfway point, and so hopefully it'll finish this. And I think. And I never did go back to track down what the actual error is, but I think that the issue is if I don't home it with that G28 before I try to do anything, then it gets confused somehow. Don't mind this tube. This is the Bowden tube that should be in here if I were running some roll off to the side or whatever, just to keep the filament under control and coming in at a better angle. But I'm loading these little samples up at the top. I normally don't like putting filament on the top of the printer just because it puts a lot of mass up at the top, and that to me creates like this inverted pendulum type thing that might be a little bit unstable. So it looks like it's doing all right. Yep. It's going to be printing out here in our, and you could look here and you can kind of watch it, you know, it's doing the skirt around the part. And you can check to see that it's what it's actually doing, and it is. It's got a little piece that came loose there. So now we just kind of hang out and watch it do its thing. You can monitor your temperatures. And again, this you can monitor from any device that can connect to this network. So assuming you can get connected to this network, then you can watch this happen. So if you're outside this network, so this is a local network, right? It's your local Wi-Fi thing. If you're outside of that, like you're at work and this network is at home, then you can connect to it like a webcam or something like that. You just have to make sure that you have the proper security protocols in place for that connection to happen. Because if you can connect externally to it, then that means there's a potential other people can connect externally to it. And so you have to make sure that you have the correct security stuff, because once you open up that network, then everything on that network is potentially out there for someone to connect to. So you just want to make sure that you are going to be safe with that. It works completely fine if you're, you know, if your network's at home, you're at home and you're just in a different room, you got your phone, you go to this web address, whatever it assigned it, the IP address for your Octoprint server, your Raspberry Pi, and you can see this screen. This is actually just a web page is what it is. It's not software you install on your computer. It's just a web page. They do have apps that basically interface a little bit smoother, but like if you're on a phone or whatever. But that's all it really is doing, is serving you a web page. So like I said, though, if you're at work and this is at home, then you have to open yourself up to a little bit of security risk that you need to be able to mitigate to make sure that you're the only one that can access it. Because for one thing, it opens the rest of your network up possibly. And even if it didn't, this printer, if it's remote controlled, people could do malicious things with it. Well, they could send files you don't want to print, but they could also send G-code to run that could harm the printer. Most of the stuff could probably be mitigated, to where it doesn't do anything really bad, but they could tear up your printer possibly if they really, really wanted to. So you just have to be aware about that part. Octoprint doesn't necessarily give you the ability right off the bat to run to town and check on your printer at home without some extra security being in place. So looks like it's printing along. Got a little progress bar. Gives us a print time left based on the G-code that it saw. I think while it's doing this, let's look at some of the plugins that you might want to deal with. So let's see, where are our plugin manager? So it just gives a list of some of the more popular ones. I'll tell you some of the ones I like to use. One of them is not in here, so Arc Welder is a good one. Let's see. Oh, I can't actually do anything while my printer is printing. So I guess I can't even search for plugins while it's printing. So anyway, Arc Welder is one. What that does is, well, we can kind of get an idea for it over here. Yeah, here. So it is making straight lines. That's what by default slicers currently do. Is no matter what shape you've got to create, it's just a bunch of straight lines. So even if it's some curve or a wave or whatever, it's nothing but little tiny line segments. Which, when their line segments are small enough, that's fine. It looks like it's supposed to look. You'd be hard to pick up that they're just a bunch of little straight line segments. G-code does have arc commands in it though. So it does have commands instead of just G0s and G1s and all that. There are arc commands to create real arcs. And your slicers, current modern slicers, just don't take advantage of those typically. I'm not sure. Maybe there are some that... I know that you can add the arc plugin. Oh, I think we can add it to Cura, actually. Let's look in Cura and see if we can find it. In our extension... Oh, it's maybe in the marketplace. Let's see if we can find it over here. Arc Welder. There it is. Let's actually install it because I never have put it here. Let's see what that's the license for. That's fine. But you can kind of see here, converts multiple G0 or G1 commands into G2, G3 arcs. So G0 and G1 are just moved from this point to this point in a straight line. G2 and G3 are here's the center and here's a radius, and make this arc here. And so what it does is it reduces the number of commands that your G-code consists of, which isn't a big deal on file size. I mean, it can dramatically reduce the file size, 20%, 60%, depending on the shape you're dealing with. But the bigger thing is it's the speaking, the G-code having to be interpreted. You can interpret it faster because there are fewer lines to interpret. So that is usually a good thing. This Arc Welder plugin you could use in Cura. That's new, new within the past year at least, I think. Previously, it only existed over here as an Octoprint plugin. And so that's one. So you could do it in Cura and run the Arc Welder, or you could actually run that over here to do the Arc Welder. Another one that's on Octoprint is, maybe I can find it over here. Octolapse is another popular one. Let's see if we can just look at it from their web page. So it's a time lapse creator. So you do have to have some way to view your print. So a webcam that's connected to the Raspberry Pi, or a Pi cam that's connected to the Raspberry Pi. Pi cams are probably the best as far as price and flexibility. They're just these little tiny things. $9, $15 for a nicer one. They're usually a little bit lower resolution, although these are 5 megapixels. That's not bad. If you do get one of these, I would, let's see, it probably even recommends it. Let's see. Does it recommend? It doesn't actually recommend, but I would get the longer cable. So these come with a, doesn't say how long the cable is, or I'm not seeing it anyway. They come with a relatively short ribbon cable here, maybe 5 inches or so, maybe not even that long. So that doesn't give you a lot of flexibility on where to put the little camera in relation to where you put the Raspberry Pi. But they make these little ribbon cables that are 2 feet long or whatever. So I would get the longer cable if I were doing this. But this is a really simple. You just plug it into your Raspberry Pi, not through the USB. It plugs into this ribbon cable slot, and it's super lightweight. There are all sorts of housings you can print to put it in and mount it somewhere. So that's a good option. Anyway, you have to have one. You have to have some kind of camera, and there is a time lapse. You know, I turned it off, and you can't start it while the print. I should have done that. I should have actually started the print with this going so you could see what it does. Maybe we'll do another one with this going. This one's halfway done over there. But this time lapse is kind of built into Octoprint, and it's fine. The difference is that this one is not very configurable. So basically what it does is it gets a frame rate and it takes pictures on a schedule. So it just takes pictures whenever you want it, you know, whenever a certain amount of frame time has passed. Octolapse can take pictures based on the G code. So it can look at the G code and see that, oh, I'm at a new Z height. I can take a picture here. I can take a picture at every layer, but move the nozzle into a particular location. So the nozzle's not kind of jumping around in my time lapse. It's always out of the view, or it's always in the same position or whatever, so that your time lapse just looks better. So Octolapse, it does take a little bit more to install it, but or no, not to install it. Install it is just you know, put the plug-in on, but to set it up. So here's a little video of an Octolapse. That didn't play at all. See how the print head is always over here on the side, and it looks like your part is just kind of growing out of the bed. That's Octolapse, versus the regular time lapse would just take random pictures. Not random, so I guess they're the location of the print head is going to be random, and the pictures are going to be taken at specific time intervals, and so they'll look a lot more chaotic than the way these look. Let's see what this one looks like. So here, you know, they've got it looking like the print head is moving back and forth printing, but it's clearly not doing that. So those are kind of the advantages of Octolapse. You can trigger it to start at certain places, move the print head at certain places in patterns like that last video showed with the moon. So it's a much more powerful one. If you just want a little time lapse, then the one that's built in here will give you something. Let's see where we're at. Looks like we're it says there are 12 minutes left. The printer says, well, the printer says it's, oh, right. The printer is not going to update now because it is sending the information to Octoprint. So the screen over there is not current. Looking at the print, well, you can see it right here. Well, it's kind of dark in there. That's why I wanted to add the light bar, which I would have added except for the issue we had with this power supply being soldered together instead of the XT60 connectors. But maybe we can move our, I don't know, there's not a place to mount the camera right now. But we can move this camera lower. That's where we're at. I can't get it any lower than that though. So you can kind of see how it has the multicolor polychromatic look to it. You can see where some parts of it look like a steel color and other parts look green. So that's just the light effects on it. But it looks like it's, you know, halfway done or so. It's printing relatively slowly. I noticed that we had to buffer there, so I stopped for a second. So it's printing much slower than what it says. The print speed you put in your slicer, let's look at it. So we put in 70 millimeters per second for our print speed. Oh, that's there it is, 70 millimeters per second. The problem is that, let's look up speed in general. So wall speeds are half of that, right? And I'm printing in spiral vase mode, which is only walls. So I'm really only printing at 35 millimeters per second, which is kind of slow. So I could have bumped this up quite a bit more to speed up our print over here. Plus, it probably, this is a really small print, remember, it's not very big at all. And it's probably not having time to accelerate to full speed before it has to change directions. So we could probably go over here and bump our feed rate modifier. So we could go in, it's printing at 100% speed right now. We could go to 150. Oh, enter doesn't work, set. And I don't know if I can tell any difference in that. There it went. So now, moving a little bit faster. So the print speed went from 70 to 95, right? Yes, no, 105. But since we're printing walls, we're actually only printing at 52.5. So that's, you know, 50 millimeters a second is a decent speed for printing. We might get a little bit of degradation on our surface quality here. I'm trying to see, I actually don't see anything worse than what we had. Maybe. Looks fine. But it's a little bit faster. Because I'm ready to get it done. We could probably go up a little bit higher. Let's go back to this camera view. Not that one. Oh, you were, I was looking at one thing, you were looking at a different thing. But I was just looking at the Octoprint version of it. Yeah, you can't really see any worse quality there. Once it's done, we'll look and see if it looks any worse or not. But it looks fine in person. And it's pretty close to done. Here's where we've got to go. So, looks all right. And they're getting, it's tapering inward, so it's faster and faster. We've got a little bit of time left. I wanted to talk a little about this Voron printer. Maybe we'll switch over, let this thing finish its little print job here. That's kind of Octoprint, how it works. And let's talk about this printer for a minute. And then maybe we'll do some more printing with the Voron printer, this other one, another day. Because I don't know how much time we're going to run out, when we're going to run out. I must still be zoomed in. Nope, that's as close as I can get. Let me see if I can get a little bit. All right, so there it is. There's where I put the Octoprint camera. So this printer, it does have a little top over here that you can set on top of it if you really want to. For printing PLA and things like that, you wouldn't want it enclosed, though it would be actually too hot in there. It's not a heated chamber, it is a heated bed, but whenever you print PLA on this guy, normally you take the top off and put the door open. What's different about this is this is a, well, two big things. This is a Core XY printer, so see if you can see the motion system up here. The print head is on this rail. The rail moves back and forth, and the print head can move along the rail, but it's controlled by two belts. So the stepper motors are back, well, there's the top of one of them right there, but there's these two stepper motors are working in unison to control these two belts. You can kind of see the two different belts. One goes to one stepper motor A, one goes to stepper motor B, and they combine together. I don't know if you can see in the video. Let's see if we zoom in. See how the belts kind of move back and forth there, but they are being controlled by the two steppers in the back. The table just moves down, well, and up, but that's how you get your Z height. Instead of the bed moving back and forth, and this is a tiny printer for the V0. I mean, it's a Voron V0.1, so it's the smallest well, I was about to say the smallest they make. They actually don't make Voron printers. What you do is, whoops, you have to buy a kit. So I bought this kit from Formbot. It's a good kit. It's not the, the best kit for Vorons, but it's a good kit. So what you get in the kit are all of the parts, right? Like, it is a massive set of parts. Well, that's all the pictures they have. They don't have, I do have a whole Voron build series if you want to see all the parts. It's on YouTube. I don't remember what I called it. Probably Voron build log, I think. Voron build log, I think is what I called it. Anyway, I used this kit and built one. You do have to print your own parts, though. So everything that's gray is something you have to print yourself. So let's zoom back out so you can kind of get the scale of what all you have to print. In gray, I haven't even finished printing the little decorative pieces at the bottom. They were not that important. That's not too bad, except that some of these parts, I did all of them, but some of them have to be printed in a heat-resistant material because they're going to be in a, near the heat bed. They're going to be kind of in a place that's going to retain heat, and if anything gets out of alignment here, then you're not going to print very good parts if you can print at all. So let's keep the door open. So that is a downside, is you either have to buy a kit that comes with parts, which most don't, or you have to find a way to print. I did ABS, so print ABS parts. I actually printed all these ABS parts on a little Prusa Mini, and it worked fine. Now, if I were to do it again, I would use this printer to print the ABS parts for another one. I believe the next one I do, though, will be a larger version. So this is the smallest one, and you can see, this. Oh, well, you can't see with the screen covering it up. It is a, pretty small. There's our ruler. I can't get it in there quite right, but 5" by 5" by probably goes down. It's probably a 5 by 5 by 5" cube. Probably in millimeters, but it's close enough. So it's not going to print. It's not going to print large pieces. But if you are interested in, first of all, learning every piece about a 3D printer or just a machine in general, this is a good way to go. It's a little on the expensive side. The kits, well, so you can get a kit that's cheaper than this. If you go from shipping from China and just do the V6 hot end, they're down at $339. The downside, these do need a Raspberry Pi. So they don't run Octoprint. They run a software called Clipper. I guess you could set them up with Octoprint, but Clipper is the one that most people use. But that runs on a Raspberry Pi. And this even says, due to lack of chip, Raspberry Pi is in short supply. Seriously. So the kit comes without a Raspberry Pi. So that's a downside. You would have to try and figure out that part of it for any of these Voron printers. There might be some kits out there that are still shipping with Raspberry Pis, but I don't think there are. Uses linear rails. It's got a little heater for a heated bed. The stepper motor is a Moon stepper motor, really small, lightweight. One of the points of the this is called Core XY, so X and Y, and what they're talking about is the fact that they're coupled together. The X and Y motion is coupled together with the two A and B steppers through these belts, and one of the things that does is that means your moving parts, the parts that actually move, are relatively lightweight. Now I do have a direct drive setup on here. You could use a Bowden and reduce the weight even more, but this direct drive setup is using a pretty lightweight stepper motor, so it's not too heavy. And you want all of that lightweight because one of the things you typically want to do with Core XY printers is print at very high speeds. And so if you have a lot of weight to move around, that's defeating the purpose. But I do have a direct drive on this one just to kind of make it, I don't know, be able to do some flexibles if I wanted to. But you typically don't print flexibles at high speed, so it probably would make more sense to put the Bowden tube setup on here. But anyway, I didn't. I put direct drive setup. But these kits are nice. They give you all the mechanical parts that you would need, and they're not terribly expensive, assuming that you can come up with a Raspberry Pi and assuming that you can come up with a way to print the parts that you need to assemble the printer, like the parts that I have printed in gray over here. Like I said, this is the smallest version. They do have much larger ones. Voron 2.4, here we go. So you can get this guy as large as a bed that's 350 by 350 by 350, so a really huge print volume. That one you'd probably want the Dragon High Flow hot end for, or at least the Dragon Standard Flow, but at that there's only $5 difference, so I would get the High Flow one. Shipping from the United States is usually more than shipping from China. I did get mine from the United States just because I wasn't, particularly at the time, I wasn't sure how long China was going to take to ship. But these are a fun build. It takes a while to build. It's a lot of stuff you have to deal with. But if you're interested in learning, these are way more of a kit than what your Ender 3 was, if that's the printer you started with. They are also high speed. Let's see if we can, we have a few minutes. Let's see if we can go over to its dashboard. So this is what Clipper looks like with the fluid dashboard. And let's see if we can get it kind of, there we go. So apparently I'm currently throttled. It's connected Raspberry Pi. It printed one of these little prints. I don't have a camera connected to it right now. But we can home all, and well, you can't really see. There we go. It's homing. I've just got some blue PLA in it. Let's just print this vase that I already have on here while it homes. So one of the big advantages of Clipper, there's several like performance advantages, but there's also your printer configuration files are right here. So this is kind of like if you need to change something on the firmware. So on the other things, Marlin and those, we've taken the code, put it into VS Code, edited it, compiled it, put it on an SD card, loaded that SD card back into the printer, and it flashed the firmware on the printer. Here in Clipper, all you do is, oh, I want to change, this is the printer config file, so I want to edit that guy. Extruder, and full steps per rotation is 400, but I need them to be 402. I put 402 in here, hit save and restart, and 30 seconds later I have changed the E-steps. E-steps may not be the best value, example of that, because I could just change that. Oh, we're buffering again. We were buffering again, so I paused there. So like I was saying, you can just change it here, save and restart, and you flash new firmware. It doesn't, because it doesn't actually flash firmware. What happens when you run Clipper is, I'm actually going to close this, is that the Raspberry Pi that Clipper is running on is actually taking over. So it is doing all the processing. Your board, the motherboard that's in the printer, is really just controlling the steppers. And so it's just doing the stepper driver part is all it's really doing. So let's print. So I could go over here to jobs. There's that vase. I could print it. So you get over here. You've got your kind of same thing that you had before with Octoprint, where you've got the temperature panel showing the extruder heating. And the bed, actually the bed's kind of already heating a little bit. So actually the bed is heating right now and the extruder is not. So I guess it's going to do the bed first. Well, let's look at our print while this is heating, because that's not very interesting to look at. Let's look at our print that came off of this other guy. There it is. I don't see any difference in the print quality when I increased it by 50% or 150%. So there it is. It's kind of hard to get the polychromatic effect, but you can see that it's different colors every now and then, or it appears it's the same color. It just appears to be a different color, but it actually printed really well. Prusament is really good filament. I don't have a lot of it. That was just a sample, but it is a really good filament. So here's our little Voron starting out. It just did its homing routine. I do think that this one I didn't do the bed is tiny, so I didn't do a mesh level on that. I just leveled the bed and it goes from there. It's now heating the nozzle. I wanted it to get started printing so that you could see it in motion. But it's got to heat up the nozzle. Maybe you can watch this for a second. You can kind of see where we're at on heating the nozzle. It heats relatively fast, so it shouldn't take us too many more seconds before it's done. It's 9:04 right now. Class ends at 9:15. I actually think we can print. This is another tiny one, so it'll print another small, this size one, the quarter scale model one. But I think we can ramp it up fast enough to where we can get it done in that amount of time. So our Ender printed this. Now I didn't try to max out the Ender, but it printed it in let's see. Print time was 22 minutes and 21 seconds. So I'm certain we can do it faster than that. We'll let it get a couple of good layers down and then we'll increase the speed. I've got a speed modifier over here. It's already at 200%, but we'll crank it up faster to get it printed in time and see how it comes out. So we're at temperature. It's just trying to stabilize right now, and it should start it. There it goes. So I have it printing a brim on this one just because I want it to stick down for one thing, because it's going to be printing kind of fast. And then I want it to actually go in and purge, use the brim as a purge also. So it's printing at 120 millimeters a second right now. Printing the first couple of layers that are solid. I don't remember. I sliced this one in the Prusa slicer, and so I don't remember exactly what settings I used on it. Alright, so it's printing the walls now. So let's go up a little bit faster. So you might only hear the fan, but you might be able to hear the steppers changing. I actually dropped it back down, and now I'm going back up. I think we've about reached. I think we reached the speed at where it couldn't cool fast enough. We got a couple of layers in there that were a little bit uncooled. It basically has two little blower fans, one on either side, that are blowing across there, and I think they kind of maxed out. So we're doing 180 millimeters per second right now. What a lot of people do is they add supplementary fans blowing from the sides or whatever to try and cool the parts fast enough. Even if you're printing ABS, at the higher speeds, this is not even fast for some of what people do with these. Then you even have to cool ABS. But so far it's 3.5 minutes, and we're almost done. So for prototyping, getting parts out pretty quick, these Core XY, Voron is not the only Core XY printer, but the Core XY style printers will speed up the whole process. Like, they let you iterate on stuff a lot faster because you can just send a part. Now these are in vase mode, so it is kind of cheating a little bit because that's going to be faster in general. No infill at all, and there it's done. So it took total, it took 7.5 minutes, and that's with a minute, about 4 minutes of preheating. So the print time was only like 4 minutes. And there's where I was saying, oh, right there, that's where I had started going a little too fast, and it couldn't cool it fast enough. Right, that line. And then I dropped it back down, and there might be a little bit right there that should have been cooled a little better. But that's the advantage of, or one of the advantages of running something like this kind of printer, the Core XY type stuff. You're moving much less mass around, so you can print faster because you can accelerate it faster, but you can also control it better. There's less vibration, less ringing type things. And when you're running Clipper, which is actually processing on a Raspberry Pi, not on a little ARM processor on your or whatever kind of, I don't, actually not an ARM, I'm not sure what processor's on the Ender type board, but the Raspberry Pi has more processing power. It can do some algorithms that improve your print quality because it can actually process the look ahead. So it's going to look several moves ahead to see what it needs to do, and then predict what movement it needs to create to compensate for any variations, vibrations, things like that. So that's one of the advantages. We'll look at Klipper a little bit more. It's another one of those that it's going to be limited right now on the availability of Raspberry Pis, but you can get some cool stuff going with it. All right. Next time, tomorrow, we will, I don't know exactly what we'll do. We'll probably look at the Klipper and the Voron a little bit more. I should have some more materials printed, samples. I don't think I will have this, these done yet, so I won't have any data on that yet, but hopefully that's coming up soon. Oh, we still have our chocolate printer. I haven't worked on that too much yet, so we can work on that some. Looks like we're about out of time. I will see y'all tomorrow with some new things.